We're going to start with the definition. It's fairly long, so I'll write it. If you want to start copying it down, you can, but I'll for sure give you guys time after I finish to copy it as well. Okay, I'll give you guys a couple minutes to finish copying this. Okay, let's read through this together. If A and B are real numbers, which all that means is that they are not imaginary, then the number A plus BI is a complex number written in standard form. So standard form of a complex number is real part first, which is A, and we know that it's a real number because there's not an I on it. So A plus BI, the BI is your imaginary number. So standard form of a complex number is Real number first, then imaginary. Okay, if b equals 0, then a plus bi is a real number. That's because if b is 0, 0 times I is still 0, which just leaves a, the real part. So if b equals 0, then a plus bi will just turn into a real number. If b does not equal 0, then it's an imaginary number because you're still going to have that imaginary part. A number in the form bi, well, there's not a real part, it's just imaginary. As long as b does not equal 0, this is called a pure imaginary number because there's not a real part in it. It's just the imaginary. Okay, another little fact here, much shorter than the first one. Two complex numbers, a plus bi and c plus di, are equal if and only if, this little word here, IFF, that means if and only if, a equals c and b equals d. So a plus bi set equal to c plus di. What we're saying is the real parts, a and c, have to be the same, and the imaginary parts, b and d, have to be the same in order for those two complex numbers to be equal. Okay, we're going to look at adding and subtracting complex numbers. We're just going to do some examples. So we'll start with example 1. Part A, we've got 3 minus I plus 2 plus 3i. Okay, before we start working these examples, let's actually write down a few of the steps that we're going to use as we're working these. So I'll just write them off to the side here. Step 1, remove the parentheses. Step 2 will be combine like terms. Step 3, I'll just write standard form. We want to write our numbers in standard form, so real part first, then imaginary. And then step 4, if we can, simplify. Okay, when we do step 1, removing the parentheses, you just want to look and see if there's anything in front of the parentheses that would change what's going on inside. So this first complex number, 3 minus I, there's nothing out in front, so nothing's going to make any of that change. So really we can just leave the parentheses off and write 3 minus I. It's the same thing for 2 plus 3I. The only thing that's in front of this set of parentheses is a plus sign, and that's not anything that will change the numbers inside. So we can just remove those parentheses as well, 2 plus 3I. So step 2 is combine like terms. So we're going to combine the real parts, which is 3 plus 2. So we get 5. And then we'll combine the imaginary parts, negative I plus 3I. So negative 1 plus 3 is positive 2I. Step 3 is to write this in standard form. Because we added or combined the real parts first and then the imaginary parts, we naturally just went ahead and wrote this in standard form because we have real part first, then imaginary. So step 3, we've already done. This is already in standard form. Step 4 says to simplify. There's nothing about 5 plus 2I that can be simplified, so this is our answer. Okay, let's look at part B. One plus 2I minus 4 plus 2I. Okay, first let's remove the parentheses. 1 plus 2I, there's nothing going on in front of the parentheses that would change anything, so we can just leave them off. In 4 plus 2I, we have a negative out in front of this set of parentheses, so that will change what's going on inside. We just need to distribute that minus sign to everything inside the parentheses. So this becomes minus 4 minus 2I. Combine like terms. So we've got 1 minus 4 to get negative 3. 2I minus 2I is 0I. This is already in standard form. We've got real part first, then imaginary. Now step 4 is to simplify. 0 times I is just 0. So we can simplify this by leaving that off and just writing our answer as negative 3. And really you could combine those last two steps, especially in this one. If you see 2I minus 2I, you could just say, okay, those are going to cancel out and I'm just left with negative 3. You wouldn't even have to write this plus 0I part if you didn't want to. Part C. We've got 3 minus negative 2 plus 3I plus negative 5 plus I. So to get rid of the parentheses, first of all, this 3 that's out in front is just going to stay. In front of this set of parentheses, we have a minus, which is going to change things. So we distribute the minus sign to get plus 2 minus 3i. The plus sign in front of this set of parentheses doesn't change anything, so we can just drop the parentheses and write minus 5 plus I. Okay, combine like terms. We've got 3 plus 2 minus 5. 3 plus 2 is 5, minus 5 is 0. And negative 3i plus I is negative 2i. So to simplify this, we would just write negative 2i, and that's our answer. Okay, last part of example 1, part D. Three plus 2i plus 4 minus I minus 7 plus I. Okay, let's get rid of the parentheses. This first complex number, nothing's changing. We still have 3 plus 2i. Same with the second one, plus 4 minus I. But then we need to distribute this negative so that we get minus 7 minus I. Combine like terms. The real parts, we've got 3 plus 4, which is 7, minus 7, which is 0. The imaginary parts, we've got 2i minus I, which is just I, and then minus another I gives us 0i. All of that just simplifies to 0. Okay, that's adding and subtracting complex numbers. Now we're going to look at multiplying complex numbers. Okay, so there is something that's going to come up when we're multiplying complex numbers. It's a fact about imaginary numbers. So if you think about I, hopefully you know I is equal to the square root of -1. When you take the square root of a negative number, that's what gives you an imaginary number. It's because I represents the square root of -1. If we were to square both sides, we would get I squared equals, and when you square a square root, those cancel out and you're just left with whatever's underneath the root, which in this case is -1. So we get that I squared equals -1. And we're going to need to use that as we're working this next example. So this will be example 2. Part A, we have 5 times negative 2 plus 3i. So to multiply, we're just going to distribute the 5. So the 5 gets multiplied by everything inside the parentheses. 5 times negative 2 is negative 10. 5 times 3i is 15i. There's no like terms to combine. This is already in standard form. Nothing can be simplified. This is our answer. Part B. We have 2 minus I times 4 plus 3i. Now that we're multiplying two complex numbers together, we're still just distributing in order to multiply, but because these are two binomials, we have a shortcut for that, or at least a memorization hack, which is called FOIL. All that means is you're multiplying the first terms together. 2 times 4 is 8. The outside terms, 2 times 3i is 6i. The inside terms, so negative I times 4 is negative 4i. And the last terms, negative I times 3i is negative 3i squared. So you're multiplying negative 1 times 3 to get negative 3, and I times I is I squared. Okay, let's combine like terms. The 6i minus 4i, we can combine that to get 2i. Then we have minus 3i squared, but we know I squared is equal to negative 1. So let's replace I squared here with negative 1. So that gives us 8 plus 2i plus 3. And now we have more like terms that we can combine. 8 plus 3 gives us 11 plus 2i. That's our answer. All right, part C. Three plus 2i times 3 minus 2i. So we can use FOIL here again to multiply. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. So combine like terms, negative 6i plus 6i, those are going to cancel out. We're left with 9 minus 4. Replace I squared with negative 1. So we have 9 minus 4 times negative 1, which is the same as 9 plus 4, which is 13. Just a couple more. So part D. We have 4i times -1 plus 5i. On this one, we just have to distribute the 4i. 4i times -1 is -4i. 4i times 5i, we get 20i squared. There's no like terms to combine because even though both of these have I in them, just like in part C, we didn't combine -4i squared with these other terms that just have I. The i's have to have the same exponent for them to be like terms. Okay, so there's no like terms, but we can replace I squared with -1. So that gives us -4i minus 20. Okay, so there's nothing else that can be simplified here, but we need to write this in standard form. This has imaginary first and then the real part. Standard form is the real part comes first, then imaginary. So we need to write this as -20 minus 4i. That is our answer. Last one. This is part E. Three plus 2i squared. Okay, so the most common mistake on this one is going to be you're going to think that you can just distribute this exponent and put it on the 3 and the 2i. That is incorrect. So you couldn't write 3 squared plus 2i squared. That's wrong. 3 plus 2i squared means you take 3 plus 2i times 3 plus 2i. Now we can use FOIL to multiply this just like we did in parts B and C. So we get 9 plus 6i plus 6i plus 4i squared. Okay, let's combine 6i plus 6i, and let's also replace I squared with -1. So we get 9 plus 12i plus 4 times -1. So that's 9 plus 12i minus 4. Combine 9 minus 4 to get 5 plus 12i. That's our answer.